All right, everyone, we're going to do logarithmic equations using the definition. And the key for this one is to solve for the logarithm, okay? Step one is get the logarithm by itself, similar to the last video where we solved exponential functions with logarithms. I'm recording these out of order, so that's a weird thing to say, but it is your most recent video. Solve for the log, and then use the definition. All right, so let's see what this looks like. All right, we got example 4 here today. Solve the following. Part A is going to be 5 log base 7 of n is equal to 10. All right, so the logarithm's not by itself. The logarithm has a 5 in front of it. So we need to start by dividing both sides by that 5. We need to get that logarithm by itself. So if we divide both sides by 5, they cancel on the left, and the right-hand side's 10 divided by 5, which is 2. Step 1, completed. All right. Next up, we use the definition of the logarithm to convert it to an exponential equation. So the base of the logarithm is the base of the exponential function. The input of the logarithm becomes the output, and the output becomes the input. Remember, the reason this works is because exponential functions and logarithms are inverse functions of each other. And we're done, right? N is 7 squared. Well, 7 squared is 49. All right, and we could check our answer as well. We could plug it in. We could either use the definition to say, oh, log base 7 of 49 is 2. 2 times 5 is 10. Or you could use the change of base formula and plug it in on your calculator. All right, if you use the change of base formula to check this, you get 5 times the log, which would be the natural log of n, divided by the natural log of 7. And the question is this equal to 10 when n is equal to 49? And you could plug this in. Let's do it. Plug it in right now. Let's see if we got the right answer. Right? Is 5 times the natural log of n, which is 49, divided by the natural log of n, is that equal to 10? Yes, it is. Excellent. Right. And that's what we're doing in this video. Okay, part B. It's going to be 4 plus log base 2 of 9x is equal to 2. So let's get that logarithm by itself. We need to subtract 4 from both sides. So when you subtract 4 from both sides, what are we left with? 2 minus 4 is negative 2. So, definition. The base of the logarithm becomes base of the exponential function. Input becomes output. Output becomes input. So we got 9x is equal to 2 to the negative second. Negative exponent means reciprocal. 2 squared is 4. So we get 1/4 is equal to 9x. Divide both sides by 9. 1/4 divided by 9 is 1 over 36. So x should be 1 over 36, and we could check our answer here as well. All right, and that's the basics of how you can solve exponential logarithm if there's only one log. If there's multiple logs, we'll have to do it. Well, if there's multiple logs, we could actually just combine them into one logarithm. If only we had some properties that we could use to combine things into a single logarithm. We do. All right, and that'll be the next video. Anyway, last example of this one. Example 5. All right. Solve and graph both sides to check your answer. So one way of checking our answer, we already did. Another way of checking our answer is to graph it on a calculator or on Desmos. We'll be using Desmos. This won't be on your quiz or an exam because you can't use graphing calculators. But it's a really great way to practice solving the equations and visualizing what's going on here. So log base 9 of x minus 5 is equal to negative 4. So we have to get the logarithm by itself. So we add 5 to both sides. When we do that, we have log base 9 of x is equal to negative 4 plus 5 is positive 1. Using the definition of the logarithm is going to give us 9 to the first power equals x, or just x is equal to 9. So our answer should be x is equal to 9, but let's graph this. All right, so we're going to graph the left-hand side, and we're going to graph the right-hand side, and see what happens. All right, so let's go over here. The left-hand side, that's going to be a log base 9. So you can use the underscore to get the base, and then tab out of the underscore. Log base 9 of x minus 5. Should look like that. The other side was just -4. So we graph just -4 on the other side, and we see where are these things equal to each other. Oh, these two graphs cross right here. What is this point? This is the point where x is 9 and y is -4. There we go. We did it. All right. That's how I can do this group of problems.